All right. So standard normal distribution. What is that? So you've heard me say normal distribution a lot. Normal distribution, everything is normally distributed. Now we're talking standard normal distribution. I would like two different colors there if you have. This is on page 21, right? Using z-scores to compare data from different sets. Okay. All right, so here's the application for it. Okay. Jay's final score in his class was 70%, with a class average of 75%, with a standard deviation of 5. Jasmine's final score was 60%, with a class average of 65 and a standard deviation of 7. So we're talking two different classes, right? Class A, and this is class B, right? So how, like, somebody would be saying normally is like, what did you get? I got a 70 in grade 11 applied, and somebody else comes by, different class, different teacher, I got a 60. So the person with a 70 might brag, like, I did better than you, right? But it's not quite that simple because you're talking to different teachers, different circumstances. Might be that one teacher is a bit tougher on students than others, and the grading is different, and right? So this is how you kind of bring everything together, and you make a fair comparison. This is a fair comparison here. Graph a normal distribution for both classes. So we're going to go class A, and this is going to be class B. And when I made this, I figured that it would work just fine. So let me just try here. The first class has a average of 75, so I'm going to try to find my middle here. So I'm going to put the 75 there. And I have a standard deviation of 5, so I'm going to go 2, 4. Yeah, this works. So I'm using every 5. Okay, so if you're counting there, I'm using every 5th mark and make. So that's kind of like I'm making a normal distribution here. So I'm 2, 4, 5. So this is 70, and 2, 4, 5 is 65. 2, 4, 5 is 60. Perfect. Okay. And let's go to our average. We put the point up there, you make it taper off like this, never touching your x-axis, okay? And the reason is there's always a chance that something is way down the line, that there's some values like way down on either side of infinity. And so that's why, conceptually speaking, theoretically, you never want to close that curve, because there is a chance, right? And then class B, I'll do the same thing, but the average is 65. So I'm going to kind of find my middle here, and the 65 is there, and it's a standard deviation of 7. So you got to watch out for that. So I'm going to go 2, 4, 6, 7. That's 67 right there. And 2, 4, 6, another 7. Oh, sorry. Mr. Dirksen, watch out. 72 I meant to say, guys. Sorry. And then we are at 79. And I'm just going to leave it there. I know I'm kind of running out of runway there. So this will be 58, right? So 2, 4, 6, and then 7. It's 58%. 2, 4, 6. That'd be 51%. So I'm not going 3 standard deviations necessarily, but we go up here. Which curve would be flatter if you had to choose? A greater standard deviation, means that data is more spread out. So let's make this a little bit flatter. Not as, so when you look at the height of the other one, just bring it over, but then go a little lower, like there. Okay. Lower standard deviation, right? Flatter. And then, no, sorry. I need to get more sleep, guys. Sorry. Can you erase that? It's a higher, sorry, it's 7, right? Higher standard deviation, therefore flatter, dispersed, right? It's spread out. So it's more spread out. The second class is more spread out, has a slightly bigger standard deviation, so things are going to be more spread out. Can you just make sure you understand this? The more extremes you have, the flatter your curve. So let's say you have a few students that didn't show up for the test. You got 0, 0, right? Like 2 or 3 zeros. Boom, your standard deviation is going to go out. So once they show up, right, a day or two later, they write it, your standard deviation goes back down. Okay. So calculate the z-scores for each of these. Okay, so let's just make a, I'm going to grab a red pen, or you can just use a different color, but let's just situate each of them along their own normal distribution. So 70% would put you right there, right? That's J, right there. And on the other curve, Jasmine has a 60. A 60 puts you right, because this is to scale, I can actually say that this is Jasmine right there. So we each drew a normal distribution for their respective classes, and where do they fare within their classes. And now we're going to figure out the z-score for each one of them. So the z-score for, let's write down J first up there. J, the z-score for J is 70, because that's the score he got, over minus 75 over 5. And that's actually negative 5 over 5, which is negative 1. Okay, so J's z-score, that's funny, J's z-score, I didn't even think of that. But J's z-scores is negative 1, and Jasmine is scored 60, the average was 65, and we have a standard deviation of 7. And you're like, Mr. Jason, what about the percentages? A z-score ends up being unitless, so it will all cancel out. So this is negative 5 over 7, which gives us negative 0.71. So what do we make out of this? Which student is closer to the average? Jasmine is, right? Not by much, right? But is closer. So technically, Jasmine has more bragging rights than Jay compared to the class, right? Because it seems like it was a tougher course, maybe a different teacher, right? But when you compare data and you have your average, Jasmine is slightly closer to the mean than Jay. So now we're going to make it a standard normal distribution. Standard normal distribution. And what is a standard normal distribution? It's actually a very easy curve to graph. Similar to normal distribution, only has z-scores on the x-axis. Only has z-scores along the x-axis. So the middle you have your 0. So let's put the middle here, make a nice and clear mark, 0, 1, 2, 3, and here you have -1. I'm counting every 5. Z-scores. And then you go right where 0 is, you go to the top, and you just make a slide, right? I'm not asking you to put the percentages in there in this case. It's not necessary. That would only be if I'm going to ask you some questions or if I clearly say label it with all the percentages and so forth. Let's just put them where they, so J would be right there. And Jasmine, if I go, this is like 0.5 right there. This would be 0.6, so it's right about there. Conclusion. Since Jasmine Z-score places her closer to the mean, comma, she did better than J overall. I will put a note here. Note, a greater Z-score indicates greater achievement. That is very important though. Like the greater your Z-score, the better you did. So if you're like way up here, Z-score of 2 or 3, you're actually compared to the rest of the class, you're doing very well. So if Jasmine had been anywhere up here, would have done even better. There's a slight lead, but not by much, right? But that just goes to show that your actual score is not as relevant as the mean and the standard deviation. And that's where the Z-score comes in handy, okay? This is the, if you want to have this exact same type of scenario, but different questions, if you go to the textbook, I picked, watch that, there's only 2 questions there, right? There's question 10 on page 264 and question 6 on page 281. So it's not a whole lot that we're talking about. Can you do those 2 for tomorrow? I think you can. I will give that AC back to you tomorrow. Will this be on the quiz? I would have to check, but I would say probably not. But everything up until now, yes. Okay? Yeah.
So, like, will the 2 bonus questions for the AC, will there be something that goes on the quiz?
That could be. Yeah. Now that you know more, you can expect that. Okay?